Hello everyone, let's look at the next numerical number 14. A spacecraft flying in a straight course with a velocity of 75 kilometers per second fires its rocket motors for 6 seconds. Okay, so spacecraft, let's see. This is the time period, 6 seconds. Now, what we are given over here is that the rocket is traveling with 75 kilometers per second. So initial velocity equals to 75 kilometers per second. Now it fires its motors. That means it accelerates for 6 seconds. And the final velocity becomes 120 kilometers per second. So at point B, let's say this is point A and this is point B. So at point B, that is our final velocity is 120 kilometers per second. Now let's see what we have to find. First thing is to find the average acceleration. So first thing first, we have to find what is the acceleration. Now we know the formula acceleration equals to V minus U upon T. So 120 final velocity minus 75, which will be the initial velocity divided by the time. Sorry, the time is 6 seconds. So 120 minus 75, which is equal to 45 divided by 6, which is equal to 7.5 kilometers per second square. So this is the acceleration for the 6 second period where the motors were fired. Number two, the distance traveled by the spacecraft in the first 10 seconds. After the rockets were started, the motor having been in action for 6 seconds. So let's try to understand this. Now what this means is from A to B, the time period is 6 seconds. The motors were fired for 6 seconds. After that, the motors are stopped. And then we go from B to C, and we're going to label C over here. Now the motors were stopped at point B. So here we have an acceleration. Acceleration equals to 7.5 kilometers per second. But after B, the motors were stopped. So the rocket is moving with a uniform speed or uniform velocity. So in this case, from B to C, we can say acceleration will be equal to 0. So the velocity will remain constant, which is 120 kilometers per second. So from B to C, the velocity of the rocket is 120 kilometers per second. So let's try to find what is the displacement for A to B. Now we have to break it down into two parts over here. We'll have to find what is the displacement from A to B, which we will label it as, let's say S1. And we'll find the displacement from B to C, which we'll label it as S2. So let's try to find what is S1. Okay, so from our formula, S1 equals to UT plus half AT squared. Now we are talking about motion A to B. So at motion A to B, our displacement will be equal to initial velocity is 75 kilometers per second. Remember, 75 kilometers per second. Time period from A to B, time period is 6 seconds multiplied by 6 equals to half. Now we already found out what is the acceleration. The acceleration is 7.5. So half multiplied by 7.5 multiplied by t square, time is 6. So we'll just put two sixes over here. 6 square is 6 multiplied by 6. So now let's try to find out what is this. 75 multiplied by 6 is equal to 450. Okay, this is plus sign. 450 plus. Now this is 2, this is 7.5. To remove this decimal, we have to divide it by 10. So 2 ones are 2, 2 threes are 6, Now this is 5 twos are 10 and 5 twelves are 75. Now two ones are 2 and two threes are, oh sorry, this will be huh, 5 fives are 25. Sorry, this will be 15. I made a mistake over here. So now this will become 15, 15 multiplied by 9. So 15 multiplied by 9, which will be equal to 15 multiplied by 9. Oh, 1 second. 135. So this is 135. So S1 equals to 450 plus 135, which will be 585 meters. Now let's try to find what is S2. Now for that we have velocity equals to 108 kilometers per second. And remember, we have to find the time, the velocity after 10 seconds. So 6 seconds it took us to go from A to B. So from B to C, the time will be 4 seconds. So let's try to find what is the velocity. Remember, formula for velocity. Velocity equals to displacement upon time. Now here we are using this formula because acceleration is equal to 0. So from this we can say displacement equals to velocity multiplied by time. Now velocity is 120 meters per second. So 120 multiplied by 4 seconds. Everyone clear? 120 multiplied by 4 seconds, which will be equal to 480 meters. So S2 equals to 480 meters. Now let's add both the displacements. So S total displacement equals to 585 plus 480, which will be equal to 1065 meters. And that is our final answer. So the total displacement after 10 seconds is 1065 meters.